So in this question with multiple choices and multiple correct answers, so you need to distinguish the choices are, given as little squares, right? So this indicates that you should look forward to identifying not just one choice, but all that apply, okay? That is a different thing between this format and a similar format in the verbal section. Remember, we had this format with 3 little squares, but they always included like the comment, select all that apply, not in math. In math, you need to remember, please, when you see the little squares, enclosing the letter for each of the choices, then you know that you need to look probably for more than one correct choice. All that apply. Okay, so let's see. Which of the following sets of 3 numbers couldn't be the sides of a right triangle? So what hint do we have here? Well, if you think about the sides of a right triangle, the sides of a right triangle must comply with a very specific property. Which one is that? Remember?
The length. No, the leg square plus leg square equals
okay.
square.
What do we call this?
Pythagoras.
PT. Okay, PT, no problem. No need for the long name. PT, right? The PT property, the Pythagorean theorem. So, yes, so you can use that as a tool to verify the different sets. All right? Please do. Be careful, ladies. You're supposed to identify the ones that do not comply with the PT. Okay? Sometimes here, this kind of question can be a bit tricky. Yeah, because we understand, okay, I need to use a PT, verify the three sets. But be careful when you set up your numbers in order to verify this property. What is C supposed to be? In this property, C stands for the length of the longer side, or the longest of the 2 sides. No matter which one is A or B, but A and B are the lengths of the 2 legs, or the 2 shorter sides. But the longest of the 3 sides is always this. So, for example, when you compare, right? When you compare these numbers, how do you compare the numbers? Say, for example, here, which one should be C? In choice C, which one is supposed to be the length of the hypotenuse?
Yeah, the last one.
The last one, right? That's the longest. Yes, okay. So, when you verify this, well, actually, these 3 lengths are proportional to 3, 4, and 5. And that's a very commonplace right triangle. So, this is not. What about 1, 1, and the square root of 3? Yeah, well, if you set up this, you verify that it is not true. So that is one correct choice. What about C? If we set up this, does the equality hold true? You see, 9 plus 3 equals 11. This is 12. So, no. Another correct response. Because we're looking for the ones, the sets that couldn't be the sides of a right triangle. If they could be, they would comply with a PT. What about D? Okay, D is a bit tricky because you see 3, 4, and 5 and suddenly, oh, this follows the proportion. No. Take a look. If you square this and add the square of this, is this equal to the square of this? No, because this is 3 plus 4, 7. And here you only have 5. So it doesn't hold the equality true. So we have what? We have another set, okay? Oh, here I have to, correct something. How come this, the square of 3, and this is the square of the square root of 3, so it's 9 plus 3, it's not 11. Suddenly I didn't recognize my own handwriting. This is the square root of 3 squared, so that is 3 plus 9, that is 12 obviously, so the equality does hold true. Okay, so that is not a correct choice, because these 3 sides could make, right triangle all the way. Say, for example, you have 3, the square root of 3, and 2 times the square root of 3. No problem, okay? That's okay. Well, what about the last one? Yes, the last one, right? Because you have 1 square plus 2 square that equals 5 square? Never. So this is the other correct one. So B, D, E are the correct choices.